All right, hi, Algebra 2 Trig students. It's Mrs. Leopold again. We're on Unit 1, Lesson 2, and Lesson 2 is about even and odd functions, as you can see right here. We're going to talk about even and odd functions graphically. We're going to talk about what they are algebraically, and we're going to prove whether something is even or odd algebraically, and then also look graphically. So let's get started. I skipped the first warm-up. That was a review lesson 1. You should definitely do the warm-up and you should check the answers and the answer key, but I did not take time to do that now because I'm trying to make this video a little bit shorter. Warm-up 2 and warm-up 3, there really aren't any wrong answers, so you should just pause, talk to people around you. You know, what do these functions have in common? And what do these functions, or which one do you think doesn't belong? So just have a go. I would say pause for warm-up number 2, do warm-up number 2 and warm-up number 3, and then unpause and, I don't know, see what your thoughts, how they compare to mine. There could be tons of different things. I'm not going to mention all of them. All right, so the warm-up number 2, you might have looked at domains of these different functions. You might have looked at ranges. You might have looked at sharp points versus curvy parts. But really, the big idea, one of the things we hope you noticed, is that letter D doesn't belong because it does not have y-axis symmetry. So A is symmetric. If we were to fold the graph over the y-axis, one side would lay on top of the other. B is the same, E the same, F, and C. So all of those graphs, if we were to fold over the y-axis, these points on opposite sides would match up and they would lie right on top of the other. Warm-up number 3, what about these functions? What do you think they have in common? Which do not belong? So have a look. Remember, the whole idea today is about symmetry. So pause and have a talk with people around you and just make some notes. What do you notice? What do they have in common? Which one doesn't belong and why? Okay, now we're talking about symmetries. We did in the first example here. I'm going to talk about symmetries again, because it is relative to even and odd functions. So number 2 and number 6 were the ones that hopefully you noticed at some point do not belong, and that is because you cannot rotate them 180 degrees and get the exact same picture. So they don't have rotational symmetry or symmetry about the origin. In geometry, we called that point symmetry. If you could rotate it about a point right here, the origin, you can rotate it. So this point, when I rotate 180 degrees, is going to go here. This point, when I rotate 180 degrees, is going to go here, etc. So if you turn your paper exactly upside down, then graph 1, graph 3, graph 4, and graph 5 will all remain the exact same with relationship to the origin. 2 and 6 will not, because if I were to rotate this 180 degrees, this point would no longer be 3 units above the x-axis. Instead, it would be 3 units below. So it would change the graph and it would no longer look the same. All right, so that leads us right into even and odd functions. Graphically, even and odd functions. So if a function is even, then that means its graph is going to be symmetric with respect to the x-axis. The y-axis. So if I draw that line of symmetry down the y-axis and I folded my paper in half along that y-axis, then the left-hand side and the right-hand side would overlap each other and be identical. So if you're looking at something graphically, that means the graph should be symmetric with respect to the y-axis. Now, algebraically, we're going to do that later on in this unit, but what does that mean? What does this mean right here? So it says when I have my y value, so if I input some x value, then I get a y value as a result. That's an ordered pair on my graph. Well, if I put in the opposite of my y value, I should still get the original. Sorry, if I put in the opposite of my x value, I don't know why I keep confusing those two words, apologies. If I put in this negative sign means opposite. So if I put in the opposite value for x, so here's my original x value, and I get this y value. So it's x comma f of x. If I put in the opposite of that x value, I'm going to get the same y value as the original, so this y value does not change. So when I put in the opposite of x, it still equals my original y value. So you can see that makes sense. If I put in x, I get y. If I put in the opposite of that x value, I still get the exact same y. You can see that in this parabola here, and that is symmetric with respect to the y-axis. If you have an odd function, this is symmetric with respect to the origin, which means it has rotational symmetry, which means I can rotate about the origin, turn my paper 180 degrees, exactly upside down, and I should see the exact same graph. So what does that mean algebraically? That means if I put in my original x, I'm going to get my original y. So I put in my original x, I get my original y. If I put in the opposite of x, I don't get my original y. If I put in the opposite of x, it doesn't go back up here and it's not reflective over the y-axis. Instead, it goes to its opposite direction. So I get the opposite value for my y. So this also changes to its opposite. Now, if neither of these things happen, we don't get the opposite of the original function, or we don't get the same as the original function, then it's neither even nor odd. So graphically, what it means is if your graph does not have reflection over the y-axis or does not have rotational symmetry with respect to the origin, then it would be neither even nor odd. All right, so look at these examples and try to figure out which ones are even, which ones are odd, and which ones are neither. So I'm not going to do these with you now. I'm just going to pause. You should pause as well and try these on your own, and then check back to check your answers. All right, did you get odd for the first one? You can rotate it, turn your paper upside down, you'd see the exact same relationship of all those points relative to the origin. B is even because it's reflective over the y-axis. C is neither. You can't fold your paper in half and you can't rotate it and see the same thing. D is also neither. E, you should have gotten even, and F is odd. And then these last three, hopefully for this first one, you got that this is even. It has reflection over the y-axis, that's even. The second one, letter H, should be neither, right? It doesn't rotate and see the same thing because this distance is different than this. It's not going to rotate, be the same with respect to the origin. And I looks like it's even. You might think, oh, this is even, except for this open circle versus closed circle, open circle versus closed circle, right? If I were to reflect here, that would switch to its opposite. So we can't put an open circle on top of a closed circle, then they're not folding and being identical to each other. So this is actually also a neither, again, because of this exclusive sign versus an inclusive side. And so we've looked at graphs to determine if they are even or odd or neither. And now we are going to spend the rest of this lesson doing examples to verify algebraically if something is even or odd or neither. If you're going to verify algebraically, then you need to put in a negative x or the opposite of x, and then you need to compare that result to see if you get the original function, if you get the opposite of the original function, or if you don't get either of those, right? So I'm going to take x and substitute all the x's with a negative x. Then I'm going to compare my final result after I simplify it. If I get the same as the original function, then I know it's an even function. If when I put in the opposite of x, I get the opposite of the original function, then I know it's an odd. And if I don't get either one, it's neither. So let's practice it so you know what I'm talking about. So I put the rules up here to remind us. If we put in the opposite of x and we get the original function, it's going to be an even function. If we put in the opposite of x and get the opposite of the original function, it's going to be odd. And if we don't get either one, then it's neither. So what does this mean? So we are going to, so before we do the math, it might be good just to kind of identify. So this is the original function. The original function is just x cubed minus 6x. The opposite of the original function, actually I'm going to move that below, apologies. The opposite of the original function is just taking a negative of my original function. So my original function was x cubed minus 6x. So I'm taking the opposite of that. So when I distribute my negative, my opposite of the original function is negative x cubed plus 6x. So here I have, if I get f of x equals x cubed minus 6x, then I know I have an even function because I got the original function. If when I put in the opposite of x, I get negative x cubed plus 6x, then that would be negative f of x, which means the function would be odd. And if I don't get either one of those, then it's going to be neither. All right, so let's do it. So I'm going to take my f and I'm going to substitute in the opposite of x. So this now is becoming negative x. So I'm going to substitute negative x in for x up here in my original function. So I get a negative x, I cube it, and then minus 6 times negative x. So now I need to simplify that. Well, a negative x times a negative x times a negative x. Hopefully you're saying a negative times negative times negative is negative. So I get negative x cubed, and then a negative 6 times negative x. Well, negative times negative is positive, so that becomes positive 6x. So this is what I end up. When I put in the opposite of x, or negative x, I end up with negative x cubed plus 6x. Is that the original function that I started with? No. Is it the opposite of the original function that I started with? Yes, it is. So that ended up being the opposite of y, or the opposite of f of x, so negative f of x. So that means when I put in the opposite of x, I got the opposite y value. And so therefore, what does it mean when I get the opposite y value? That means my original function is odd. These 3 dots right here mean therefore. So you need to write this statement when you're stating if something is even or odd. You need to actually write, so f of negative x equals negative f of x, therefore it's odd. And you have to show all of this work. And the reason we're doing it for x values, you can't plug in numbers, because of one number, you're just proving it for one simple math calculation. You can't just do one simple math calculation. You have to prove that this is true for all x values. So by putting in a negative x, you're proving it for all x values. All right, let's try the next one. I see my original function. It's x to the 4th plus 2x squared. Now, what is the opposite of the original function? Well, I'm going to put in a negative, and then I'm going to have my x to the 4th plus 2x squared. But when I distribute that negative, I get, let's use red, I get negative x to the 4th, and then a negative is positive 2x squared. So the opposite of the original function is negative x to the 4th plus 2x squared. The original function is here, x to the 4th plus 2x squared. Oh, apologies. I see I made a mistake here. This was originally plus, so now when I distribute my negative, that should be a minus sign there. So it's negative. So it's negative x to the 4th minus 2x squared. Apologies. So now I'm going to actually test, and I'm going to put in the opposite of x. So I take x, I put in a negative x, So up here where it's x, I'm going to put in a negative x and take that to the fourth power. And here where it's x, it's 2 times. I'm going to take a negative x and take that to the second power. Notice I'm parenthesizing my negative x. You need to make sure you're parenthesizing. Now when I simplify, right, a negative x times negative x times negative x times negative x, that's 4 negative x's, so that's a negative times negative times negative times negative. That turns into a positive x to the fourth. And negative x times negative x squared, that negative x times negative x is just turns into a positive. So I end up with x to the fourth plus 2x squared. Well, x to the fourth plus 2x squared is the same as what? It's the same as the original function. So when I put in the opposite of x, I got the original function. So when I put in the opposite of x, I got the original function. Therefore, my conclusion is that this function is even. All right, try these next two on your own. We'll remind ourselves if something is even. That means when you put in the opposite of x, you should get the original y value. When it is odd, and you put in the opposite of x, and you should get the opposite of the y value. And if you don't get either one of those, then you know it is neither. So for letter C, these are a little bit trickier, so I'll go ahead and look at these together. So for letter C, I would encourage you to multiply this out. So f of x equals x minus 3 squared, so that's x minus 3 times x minus 3. Well, if I were to FOIL, I get x squared minus 3x plus 9. So my original function is x squared minus 6x plus 9. Now the opposite of my original function, I'm just going to take the negative of the original function. The original function is x squared minus 6x plus 9. So when I distribute that, I get negative x squared plus 6x minus 9, right? I'm distributing, so those signs change. So this is the opposite of the original function. So now I'm actually going to test which one of these happens, either one at all. So I put in the opposite of x. So I like to write everything out first. So I'm going to put in the opposite of x to my original function. So here's my original function. I'm now substituting in all of my x's with negative x. So I'm going to have a negative x in here. I'm going to have a negative x in here. And I see what I did here. I'm not sure why I have all these mistakes today. Apologies. I'm putting this into my original function. This is the original function. So it should be x squared minus 6x plus 9, except I'm substituting in a negative x there. So when I simplify, what do I get? Well, negative times negative, it becomes positive x squared. Negative 6 times negative x is positive 6x, and then this is plus 9. Now, this is what I get as my result when I put in the negative of x. Is that the same as the original function? No, it's not. It's positive, negative, positive, so that didn't work. Is this the same as my opposite function? Is it negative, positive, negative? No, it's positive, positive, positive. So therefore, what happened this time? Well, hopefully you're saying when I put in the opposite of x, it did not equal the original, nor did it equal the opposite of the original. Therefore, this function is neither even nor odd. So this was an example of a neither situation. All right, pause, do letter D on your own, and then we can check back together when you're done. Okay, and for this last one, did you get that it was an even function? I hope so. If not, then look at the work above. So this is the original function. I took the opposite of the original function, so I changed the signs, and then I tested by putting in the opposite of x. So when I put in the opposite of x here, well, that negative x quantity squared turns into a positive, but this negative in front makes it go back to a negative, and the 6 doesn't change. So what does that mean? That means I got the original function. So when I put in the opposite of x, I got the original function, f of x. Therefore, that means that this is an even function. It's reflexive about the y-axis. Reflective, sorry. All right, it's kind of challenging to explain that on a video, so please reach out, ask your teacher, ask me. You can seek out more help if you want on YouTube or at Khan Academy, but yeah, we're here to help you as well. Bye.